Good afternoon, good morning, everybody, depending on where you're calling from. Welcome to the open house of the Responsible AI for Ukraine program for fall 2025. My name is Julia Stoyanovich, and it's my pleasure to be running this program together with several other amazing people who will also say hello to you in a couple of minutes. I direct the Center for Responsible AI at New York University, and this is a flagship program of our center. We started it, so this is the fourth year, right? We started the program immediately following the Russian invasion of Ukraine. And the goal of this program is to make sure that talented students such as yourselves have a sense of normalcy during these unimaginably difficult times, and that you are able to connect with a network of international researchers in artificial intelligence and responsible AI as well, and that you're able to have fun while working on these really interesting projects. And so in addition to directing the Center for Responsible AI, I also have an appointment in computer science and engineering. So I'm a computer scientist by training and by practice, and at the Center for Data Science at NYU. Um, and this year, in this fourth round of the program, we have an amazing turnout of both student applications and applications from mentors to lead these student teams. So what we will do today is I will first just say a couple of words about the program, introduce a few other key people, and then we will dive into project descriptions so that all of you students can make an informed choice about which projects may be of interest to you. And maybe, Anya, you could paste into chat the link to the project description folder simultaneously so that people can then take a look as we're speaking and decide which interviews they want to attend. And then once you have gone to the interviews, there will be the next step where mentors are going to rank students and students will rank mentors. And then we will decide on an assignment, hopefully that works for everybody. So a quick summary of this program. We started in June 22. So far, we have graduated more than 70 research fellows from 12 Ukrainian universities. This year, we received a record number of applications, 88 applications for this term. And there are 69 mentors, of whom 21 are new this semester. And this is really wonderful that this network is growing from 32 institutions around the world. And one of the things that is different this year is that some of the mentors are actually going to be people who have been students in this program, who are responsible AI research fellows, and they have been with us for a while. They have done really well in the projects, and so they are now serving together with a faculty mentor as junior mentors for some of these teams. We have 12 countries represented, over 40 projects have been completed, and I'm very happy to say that this work has so far resulted in 17 peer-reviewed publications to date, and many more are coming, I'm sure. Um, so here I'm just giving a very quick snapshot. So all of the publications here are just from this year, 2025. And on all of them, you will see that there are Ukrainian students as well as international mentors appearing as co-authors. We publish in a range of venues. I'm highlighting a Nature communications paper that just came out. Uh, Also several papers in security, in data management, responsible data management, and also, we have a paper in FACT, the FACT conference, and several other venues. So again, this is just a snapshot. Please take a look at the program website for more information about some of the outcomes. And now I'd like to introduce Anya. Anya, please say a couple of words. Just say hello.
Yes. Hello, everyone. My name is Anya, and I work with Julia at the Center for Responsible AI. And I'll be helping run operations on the New York side. RAIforUkraine has become a truly remarkable global program, and I'm excited to support Julia in managing its next stages. So I wish you all a great semester, and I look forward to seeing and sharing the exciting results of your collaborations.
Amazing. Thank you very much, Anya. Welcome on board. And Yaroslav, over to you. Yaroslav has been an amazing supporter of the program since the very beginning, and thank you for making time in your busy schedule to
Yeah.
join.
Thank you very much, Yulia. Thank you all. It's my big pleasure to be here today. For years, when we just started this program, I was the Dean of Applied Sciences. Now I went from faculty level to the rectorate. But nevertheless, I really care about this program. I'm very proud about this program. And these numbers that Yulia showed indeed shows the growth in quantity and in quality of the program. I'm really amazed about the applications of this year. I am glad that there are many applications from what we call frontline universities. So those universities that don't have such good possibilities to study alive, on their classrooms, but should study online. And this program will help them actually will help you to feel this sense of normalcy also online. But anyway, this is a research program, and this is something very exciting and something that brings you not only this normalcy, but can actually increase and can empower you for really great future projects, research projects. I know many say graduates of this program who were bachelors but then started their study on master level, continuing research in responsible AI. Now some of them go to PhD studies, and this is really great to see how students grow and how our research capacity in Ukraine and in the world grows in responsible AI. Also for the Ukraine Catholic University, this is a very important project. We call the New York University project here, unofficially. But we also decided to institutionalize this project, to start a new center here that also will take care about this project and projects like this in order to make this sustainable, in order to make more, to help our government, to help our society to make more responsible decisions based on data. And I'm happy that Tanya Zakharchenko is coordinating this program from our side and will lead this new center that I hope you will hear news about this month. Thank you very much and good luck.
Amazing. That's fantastic news about the new center. This is exactly the kind of an outcome, right, that we want to support. Thank you very much, Yaroslav. And now over to Tanya.
Yeah, hello to everyone. I'm Tanya. I also, for now, director of the computer science program at Ukrainian Catholic University, and I'm so happy to be the coordinator of this amazing program that was established by Julia 4 years ago. And thank you so much, Julia, for your ongoing support over the past 4 years. It's really, really valuable for us. I will continue to say that this program gives Ukrainian students unique chance to collaborate with leading researchers worldwide, even when they cannot leave the country, because I guess you know that for men, for example, it's quite complicated. And of course, as the person who coordinates this program on Ukrainian side, I will share just a little bit more about students' applications this year. Can you click on the next slide? Yeah, thank you so much. So Julia already shared that we have 88 applications compared to almost 60 last year, and we have a representative from 19 Ukrainian universities. That's really, really large amount, and now we have 52 accepted for the second round students from 14 universities. And as Yaroslav said, I'm so happy that we have representatives from Dnipro, from Kharkiv, from Zaporizhia, so from the universities that's really close to the front line. Anyway, I also want to thank to all the mentors, because this growth definitely would not have been possible without your dedication, your time, your energy in supporting our Ukrainian students. And enjoy interview meetings today. And I guess we can jump to project presentations. Thank you, Julia, again.
Thank you, Tanya and Yaroslav, for your support, and Anya for everything that you are already doing for the program. So here's how we're going to run this round, right? So we have 52 students here who moved on to the second round. And we have 16 projects, I believe, that are taking new applications. And these teams are, by design, teams of 2 students. Sometimes we have 3. In rare cases, we might have 4 students, right? So this year, it looks like we're going to need to sub-select slightly from the 52, but we will see. We will see how things go. So just go to the interviews that are for projects that are of interest to you, right? Don't try to go to all of them. Pick a few, 2, 3, 4, I'd say, right? Every project is going to be presented, hopefully, by one of the mentors, if they are present here. If not, I will substitute for them and I will give you the project descriptions. Importantly, the interview dates and times are on the right of every slide. So be strategic about which interviews you attend. Yeah, the first round is going to be today after the open house. And when we present these projects, this is for all the mentors, please keep your presentation to 2 or at most 3 minutes, because otherwise we're just going to run out of time. We have a lot of projects here. In my slide deck, I have presentation notes. If any of you want to look at those, these are concise descriptions. So you can just use those in your presentation if you like. So to start, I see Mikola is here. So Mikola, would you like to say hello and present your project, our project?
Of course. Hello, everyone, and glad to be part of this program. This is the project we'd like to put forward together with Julia. It's about AI safety, and we call this project AI Safety Labels. Well, the main motivation is to address the growing need in developing standards around AI safety. So on this project, we would like interested students to look into a particular case study and use that case study to come up with a way how to quantify the safety of a particular AI agent. There are some interesting starting points to look at. Some of you might be familiar with initiatives like data sheets, model cards, nutrition labels. And we would like to go beyond that and bring in together the model perspective and data perspective and project it into AI safety domain. So I think this is a very high level overview in a nutshell, and will be available today in 2 hours to discuss this project in more detail. Thank you.
Great. And we do have time maybe for one question, if anyone has questions. We don't have to entertain questions at this point, but if anybody has a burning question, please ask. You can look, of course, at the project descriptions for details about the deliverables and prerequisites for this project as well as others. Any questions? If so, speak up. If not, we're moving to the next one. And this project is on AI-powered species detection in underwater imagery. This is really exciting. We've not had a project before on this topic. Are any of the mentors here? I think I saw Leo.
Yeah, hi. Can you guys hear me?
Yes. Hi.
Lovely. Yeah, it's quite an exciting field. So hi, my name is Leo. I'm with the Norwegian University of Science and Technology. The main supervisor is Martin Ludvigsen, which is also my supervisor. I'm a PhD here in underwater robotics, and we have Giacomo Mon and Ariel Friedman joining us from Australia. So it's quite a diverse, a big group of people that want to work on this. And the issue basically is we are all in
I think we lost Leo.
underwater robotics, and we want to try to understand. Oh, really?
No, it's okay.
Am I back, or
Yeah, you're back. Yeah,
where did I cut out?
just keep going.
All right. Well, basically, the limiting thing is that we take a lot of images underwater, but we're really struggling to extract information. So usually we have then biologists going through hundreds of thousands of images and really clicking on each species or plant that they can see in those images. And now we have a huge data set that we have access to that Ariel Friedman and Giacomo Monk built up in Australia. And we want to build classifiers to take away this load from the biologists so that they can concentrate on what is really necessary, the hard task of identifying, more exciting species than sand and stone.
Okay, that's the description, yes?
Yes, that is the description. Sorry, I should have maybe ended with that. So yeah, for you guys, there's a lot to do, a lot to experience there. We have a lot of data and experience with the data. So we have, first half of the project quite clear what we would like to see, and then we can become a bit more flexible because there are a lot of things that can be done with that data. So, and I'll end here.
Amazing. Yeah, so one of the prerequisites here is motivation to contribute to advancing our understanding of the oceans, right? All the other prerequisites are sort of standard, Python, etc., right? Any questions quickly? Okay, thank you, Leo. So we are moving
Thank you.
to the next project. George, are you here? Yes.
I am.
Please introduce the work.
Okay, thanks, Julia. Hi, I'm George Fletcher. I'm a professor in Eindhoven in the Netherlands in the Math and Computer Science department. And this project is part of a longer running, larger project that Julia and I have embarked upon a couple of years ago, where we are trying to take methodologies and tools from, let's say, the social sciences and humanities and bring them into computing and data science, in particular around questions around justice and responsibility. So in this project, we're looking at how data models get designed, right? So if you think about any data set, it manifests some conceptualization of the world, like HR will have people, employees as things, departments as things, and then relationships between these things. Right, so this sort of conceptualization is key to the design and deployment of any information system. And so in this, we're looking at how these conceptualizations come to be and how we might have broader voices in the conversations around the design of these conceptual models. And so last year in the last projects, we had a focus on bringing tools around participatory design coming from industrial design into conceptual model design. And there we developed an approach to have wider range of voices involved in conceptual models. And so this year we'd like to continue this project and look at pathways to impact, right? So last year we spoke primarily with practitioners and professionals. And so this year we'd like to look at how to make impact in education. So how can we bring this methodology that we developed last year and bring it into the classroom? And so this is, that's in a nutshell what this project is about.
Great. And then also I should add that this work has already resulted in a couple of publications. We've been doing this for a couple of years. And one of the students who's worked with us is now doing a PhD at UKU with Tanya as her supervisor and George and me as co-supervisors. So this is one example of a kind of an outcome that one can expect. Any questions? Yeah, maybe let's leave questions to the end, since it doesn't seem like people have any or many questions. All right, so the next project is on responsible edge intelligence. Is the mentor here? The mentor is Farhin Ayaz from City St. George's University of London. And she's a new mentor this year. So I don't see her, so I'm going to give an introduction. And by the way, at this point, we have switched to projects which will have interviews tomorrow, right? Up to now, we saw projects with interviews today after the open house. And now we're talking about tomorrow's interview projects. So what is this about? A cloud-based machine learning enables scale, but often falls short in latency, privacy, and reliability for emerging edge intelligence scenarios. Edge machine learning addresses these challenges by running models directly on user devices. This is what we mean when we say running something on the edge. while online learning allows models to adapt continuously to new data. Combined, these approaches support privacy-preserving, context-aware, and responsive AI systems. This project will focus on developing responsible on-device online machine learning models that can withstand adversarial attacks, ensuring robustness and security in real-world applications such as autonomous driving. Students will design lightweight, adaptive models that align with responsible AI principles of security, reliability, privacy, and fairness. If you have any questions about this, please ask them during the interview tomorrow. Okay, moving now to the next project, and this is reliable estimation of patient outcomes in oncology. Do we have any of the mentors here?
Yeah, hello. Could you hear me?
Yes, we can hear you fine. Thank you for joining.
Perfect. Yeah, I'm super happy to join this program. I actually regret not knowing about that like previous year or before that. I did my bachelor's in Kiev. I'm also Ukrainian, and then I moved to Munich for master's in data science, and now I'm about to finish my PhD. So I'm kind of in the transition between PhD to the postdoc. And in our group with Stefan, we do a lot of causal machine learning. And we have a lot of both theoretical and practical projects in the realm of causality, which is like super relevant for reliable machine learning. And we have our main focus is more applied part of the causality. We don't do like a theory of causal diagrams or some very abstract theory for like assumptions, etc. So we actually ask ourselves what are the minimal methods and minimal assumptions required to do a reasonable personalized treatment effect prediction or personalized prediction of the patient outcomes. And we have several data sets with the cancer patients, and the main task would be to first evaluate how effective are existing treatment policies, and ultimately to find a better personalized treatment regimes. Or, for example, in many, like there are already so many widely used practices, but then whenever there is a combination of some treatments, nobody has ever done any studies on that. So there is a lot to explore, and I expect the students to have some good experience with Python or some basic machine learning projects, but then the causality part we can, I think, because there's a lot of time, we can do some introduction on that. So it's fine if somebody never worked in the causal machine learning or causality.
Yeah, this is great. Thank you very much. Let's maybe when we describe, we don't have to talk about the prerequisites because the students all have access to the right?
Okay.
In general, right, for all the projects, they are going, these are research projects, so they're going to go deeply into some area. And we don't expect students to come in with knowledge of that. We expect them to be interested in the general topic, right? And then we'll catch you all up. As long as you can program in Python, for example, you should be fine. Yeah, good. Okay. Thank you, Valentin. And this interview is tomorrow. The next project is called Towards Efficient Orchestration of Generative Models for Distributed Inference Services. Whom do we have?
Here we are. Hello, can you hear me?
Hello. Yes, we can hear you. Hi, Francesco Maria.
Hello. So first of all, thank you so much for this program. It's a great program, in my opinion, and thank you for the chance, for the opportunity. So I'm Francesco Maria Faticanti. Currently, I'm a postdoc researcher at the École Normale Supérieure de Lyon, but in October I will join IRIA, the National Institute of Computer Science in France, as a researcher.
Congratulations.
So, thank you. So basically, just to introduce briefly the projects, The problem we would like to investigate is about how we orchestrate the application nowadays. Because nowadays the application basically consists of different software components that we call microservices, and each microservice is devoted to a specific task within the application. And there are different challenges that we are facing when we have to deploy this application on a distributed infrastructure. So basically, in distributed systems, we have constrained resources, and we have some requirements to satisfy from the application side. And so there is a need of orchestrate these applications to satisfy the objectives of all the involved stakeholders. So the needs of this orchestration is further stressed by the introduction of machine learning models as components of this application, in particular with the generative tasks given by for example, large language models used nowadays. And there is this fusion of inference serving systems. And so the objectives of this program, of this work, will be to investigate what are the main algorithmic challenges, both from theoretical and practical point of view, to orchestrate this application when we are dealing with large language models, basically. And the work will depend also on the specific interests from the students. We have both contribution to give, both from the practical and theoretical point of view. So thank you for the introduction, and I hope to receive more questions on the interviews.
Fantastic. Thank you very much.
Thank you.
We're moving to the next project. And this project is by Sihem and Noha. It's called Lever, Leveraging Efficient Vector Embeddings for Reusable RL or Reinforcement Learning Policies. Do we have Sihem or Noha here? Okay, if not, I'm going to just give the introduction. So reinforcement learning, or RL, is widely used for decision-making tasks such as product search, grid traversal, and quiz design. However, RL training is costly, requiring extensive exploration and retraining whenever new reward signals are introduced. This project aims to make reinforcement learning more efficient by enabling policy reusability without retraining, focusing on combining pre-trained policies at inference time. To achieve this, the project will explore the use of vector databases to encode, store, and retrieve policies, allowing multiple policies to be combined on the fly. Building on prior work that provides guarantees for additive reward functions, students will train policies in education settings, generate embeddings, and evaluate retrieval performance across different vector database systems. So the reason that Sihem is not here right now is because she and I both are in London, actually, at a conference called VLDB. This is one of the main data management conferences. And at this conference, there's going to be a paper presented in a workshop on Friday that is the outcome of last year's project that Sihem and Noha supervised. So they have been with the program for quite a while and are really amazing people to work with. Sorry, I'm not giving similar introductions and descriptions for others, but just to explain why the mentors are not here. So if you'd like to learn more, please come to their interview tomorrow. Okay, the next project is called SQL Without Nulls. Is Leonid or Liat here? And they also have been with the program for quite a while. So let me give the introduction. I know Leonid is also at this conference right now. So SQL is the query language that we use in relational databases. SQL is one of the most widely used programming languages, but it suffers from long-standing design limitations. A particularly problematic feature is SQL's handling of nulls, unknown or inapplicable data, represented using three-valued logic, which often leads to programming errors. This project investigates a radical approach, eliminating nulls altogether by fully normalizing data into the so-called sixth normal form. And you will find out what that is if you join this project. Students will study how queries must change in this no nulls representation, extending existing translations of select from where group by having queries with primary key and unique constraints, and evaluate both performance and design implications. So for you to be successful in this project, it's helpful, in addition to Python programming, also to have some SQL background or data management more generally. Okay, so I'm now moving to the next project, and this is AI for multilingual misinformation and propaganda detection in the context of the Russian-Ukrainian war. Are Nina or Ksenia here?
Yeah.
Hello.
Can you hear me?
Yes.
First of all, thank you very much for inviting me for this very useful project. And our project, small project, proposed from Umeå University, Sweden, and Stockholm School of Economics, Sweden, also. And the main idea of our project is textual analysis of the textual data that related to the Russian-Ukraine war. In particular, it's very, first of all, it's a very practically oriented project. We have some textual data from the established outlet like BBC, CNN, Russia Today, and so on regarding the war. And we have the data from the Russian bloggers. And our idea is to investigate the correlation between the official information, between the most well-known event of our war and then reflections, this or pre-information before this event in the Russian bloggers' textual information. For this, we are going to use sentiment analysis in order to decide positive and negative, topic modeling in order to consider the correlation between the topics, aggressive analysis, and some other AI methods to study text, to investigate the text. Thank you.
Great. Thank you very much, and welcome to the program. Really happy to have you.
Thank you.
The interview for this project and the ones that are following it are on Friday, right? So we just switched from Thursday to Friday for the students to take note. All right, the next project is called LLM for ORM, exploring LLM, large language models, as energy efficient alternatives to object relational mapping, or ORM frameworks. Would any of the mentors like to present?
I can take care of that.
Yes,
Thank you. So I'm Romain Rouveau, I'm a professor at the University of Lille and part of this team. So we are a software engineering research group and dealing also with a distributed system. So the idea of this project is to explore actually how the introduction of a large language model in the practice of software developers have some benefits for the development of microservices, like mentioned Francesco Maria, or other online services. So we observe that these LLMs are widely used by developers nowadays who rely on services like GitHub Copilot to develop their system. So the objective of the project is to see whether the adoption of such LLMs have some benefits to both efficiency of web services that are deployed and also energy consumption, which is another dimension that we'd like to take care of. So we used to adopt an empirical approach based on the development of benchmarks in particular. So the idea is to develop a set of benchmark application that we can use to conduct an empirical study comparing the performances of the different strategies that can be applied, and then see what we can recommend to software developers and to which extent we can improve LLMs to make better recommendation for developers.
Fantastic, thank you. And Romain and Pierre and Belkis have been with the program for a couple of years, right? So
That's
I'm, yeah, I'm glad that you are continuing to work with us. All right, so the next project is called Quality Estimation of Labeled Benchmark through Logic Expressivity. Is Pierre here, or are maybe any of you also involved in this? Romain or Belkis?
Unfortunately not, so I'm not sure I can help here.
Okay, so then I'm just going to give the description, and then Pierre can tell you, dear students, more on Friday. Yeah? Okay. So quality estimation of labeled benchmark through logic expressivity. In graph learning, there is a strong link between what properties can be learned by a method and its logical expressive power, often tied to the number of variables used in the logic. This project explores whether a labeled benchmark describes a property that is expressible in a particular logic. So this is a theory project, as you can tell, but the aim is also to implement and test a new theoretical approach, evaluate its feasibility, and optimize the method as needed. And here, like in the project that talked about SQL without nulls, it's very important for the students to understand relational databases and SQL in addition to Python prototyping. Okay, I'm moving on to the next project called Physics-Informed Generative AI for Design of Next Generation Catalysts. And this is a new domain for us. We've not yet seen materials science in the program. So Andrei, please present your project.
It's my great pleasure, first of all, to join this program. Thank you very much, Julia and Anya, for keeping it running. I'm very happy to finally have discovered this program and join it. So it's my great pleasure to also present the project for the students in this domain at the interface between material science and computer science, at which I work in collaboration with the top researchers at the University of Liverpool in the UK. So the students who will join these projects will, of course, first of all, contact with me as a supervisor of this project, but will have also the opportunity to learn more about either CS or chemistry from the colleagues of mine from these two departments where I work as a research scientist. So the project is motivated by the materials and our need as a society of the new materials, discovery of the materials that will solve our problems in terms of technology, right? Any technology finally is bottlenecked by the discovery of new materials. And in this project, we will be diving into how to apply the generative AI, in particular the diffusion probabilistic models that you may have come across when trying to generate new images, how to apply these models into generating new crystal structures. Then if this is a successful endeavor for us, either from computer science perspective or chemistry in particular, and we discover structures that are likely stable with new properties, we'll be able to test and validate the discoveries in the lab, and the outcomes may result not only in the publication, but in the new materials that could be potentially patented and applied in the future in the technology. So a bright future ahead, hopefully. So if any of you students haven't yet decided on which project to apply to, I encourage you to apply to this one as well. You will learn both about chemistry and computer science during it. Thank you.
Fantastic. I want to join this project. All right. Thank you very much, Andrei. So the interviews are on Friday for this. Our next project is UHAT RE, I guess. Rule extracted explanations from hard attention transformers. do we have, I saw David, right? So
Yeah, I think Michael is also here, but I'll do the presentation. If there's any questions, we can answer. So yeah, welcome everyone. So for this project, we'll have several mentors. We'll have Professor Michael Benedict, who's at the University of Oxford and has been in this program for several years. Anna Ozaki, who's joining from the University of Oslo, who's joining this project for the first time, and myself from the Royal Holloway University of London. I participated previously, I think 2 years ago, and I'm able to come back this year as well. So the goal of this project is to, well, all of us have been working on the connection between on logic and AI traditionally, and more recently on neural networks. So the goal on this project is to work a bit on this intersection. You surely know transformers that have been a very popular machine learning model that has been used recently in things like large language models and so on. But one of the big problems that they have is that they essentially work like black boxes. We don't really understand why they make the decisions that they make, or it's really hard to verify formally that they satisfy some property, what we normally call verification in more traditional systems. So the goal of this project is to focus on one specific architecture of transformer, what we call the UHAT, so unique hard attention transformer. And you would be able to implement this variant and then test this variant on several benchmarks where the goal is to classify strings, classify inputs into ones and zeros. And then the idea is to develop this algorithm. Well, we'll provide partly this algorithm for extracting logical rules, logical explanations of why the transformer made a specific prediction. So we can have a look and check if the predictions that are being made by the transformers make sense when we extract those rules to explain them. So part of this project is mainly practical in the sense that you will be implementing this and testing in on some benchmarks, but there is also space to do a lot of theory if you wanted. So you would be able to optimize this rule extraction program, or even think about what kind of rules make sense to extract and how to make them in a very nice way. So yeah, it's mostly practical with this theoretical component, and I hope you enjoy it, and we'll have the interviews on Friday. Thank you.
Michael, please also say hello.
Hi there. Looking forward to talking to you on Friday.
Yeah. And we have a paper at a workshop in VLDB, this conference that I'm at right now, that Michael has led. That is an outcome of this program as well. So there are a couple of continuing projects that I will speak about, and I will start with two of them where we are looking for additional students to join this year. So we will be holding interviews for these projects, just like for the new projects. And the first one of them is called Virni Flow, a design space for responsible model development. And I will be supervising this project together with Denise Herasimuk, who has been with us since the beginning of the program. He is a responsible AI research fellow, and we have written many papers together. One of them I just presented at VLDB yesterday on a project called Shades of Null. So Denise, are you here by any chance? If so, I'd love for you to describe this. I don't see Denise, so then I'll speak about it, but then you can meet both of us if you're interested in this project. The interview is today after the open house. So in just an hour or so, or less. So what is Virni Flow? Virni Flow is this design space that allows data scientists to conduct responsible design and validation of machine learning models in a way that also pays attention to what happens with the data upstream from model training. And it's an outcome of multiple years of work by Denise and then a few others in scope of this overall project called Virni, where we are helping data scientists design models, assess them, benchmark different types of, let's say, missing value imputations and other pre-processing techniques, and understand how various choices that you can make during data pre-processing, but also model selection and model tuning and validation are going to impact various aspects of performance of your models downstream. So this is a data engineering project that involves working with a mature code base that nonetheless, of course, can be extended sufficiently. So we have a draft of this paper in particular that we want to work with you on archive. You can take a look. And what we're looking to do here is to extend the functionality of the Virni Flow library, make things even more efficient, benchmark performance of Virni Flow against some competing systems, and also hopefully conduct a user study where we show that data scientists whom we are hopefully helping with this system, in fact, are finding the functionality useful in the sense that it's allowing them to conduct their day-to-day tasks more effectively. And I'd be happy to tell you more about this project during the interview. The next project is called Model Explain. So this is also a continuing project where we have a RAI research fellow continuing, but we are looking for one or two more people to join the team. Lesia, are you here? And here also we have Bogdan, who is a RAI research fellow and has been with the program for a while and is now going to act as a mentor on this team. If neither of them are here, then I can introduce the work. So what is this about? It's about explainability, interpretability, one of the aspects of responsible AI very clearly. In high-stakes domains, such as lending and healthcare, explanations of algorithmic decisions are essential for fairness and transparency. However, model multiplicity, when many different near-optimal models exist for the same data, undermines the reliability of explanations. The prior work of this team introduced a framework for generating robust counterfactuals across a so-called Rashomon set of models. These are optimal or nearly optimal models that are different in some aspects of their fairness or performance. This project builds on this framework to tackle two key challenges. The first is to identify the most robust and trustworthy models within the Rashomon set. And the second is to generate and evaluate multiple diverse but robust counterfactual explanations. The aim ultimately is to design methods for robust model selection and to characterize explanation multiplicity, ultimately advancing more user-centric and trustworthy algorithmic systems. So for this project, the interviews are on Friday. And at this point, I can also tell you a little bit about some of the other continuing projects where we are not recruiting students. So maybe I will spend just a couple of minutes per project. I don't know, George, if you're still here, if you want to talk about this one. So if not, I'll just say that, oh, you are, okay, George, so please go ahead, maybe just a minute, because we're not really recruiting here, but this is just to tell the students that there will be these other projects also running concurrently.
Yeah, so this is a project that we're building upon this year in the education direction. So Victoria Makoska is continuing at UKU, the three of us together. And yeah, just so those who are interested in the project, so you can understand that this is part of a larger project, which is still ongoing. So there's lots of support around the topic.
Yeah. And likely you will interact with Victoria, right? If you join this new project as well.
Yeah, Victoria will be around. Yeah.
Okay, so the next one is KGLNN, aligning knowledge graphs with large language models. I don't know whether any of the mentors for this project are here, possibly not, because they're not looking to extend their team. So they have already 3 students, 3 RAI research fellows working with them. And this is a project that has been running for a year, and they are extending it to prepare a publication. We also have another project by Sihem and Noha called Maria, guiding teachers in question-answer generation with AI planning. So this work is synergistic with the project that they propose for which they are recruiting. So there's going to be more than 2 or 3 students working together with Sihem and Noha. Okay. We also have a team from the London School of Economics, Josh Loftus and Sakina Hansen, who have been working with us, have been part of the program since its inception. And they are interested in causal Shapley values for causal interpretability. They work on causality, on kind of the statistical angles of this work and machine learning. And that's it, I guess. Or there's one more, apologies. So there's also another project by Michael. I don't know, Michael, if you're still here, if you want to say a couple of words together with Zolt. And this project resulted in a paper that is being presented on Friday at this conference where I am at the moment. And it's about neurosymbolic AI.